Hello friends, Jermaine here and welcome to this new video series. We'll be looking at the Flutter framework essentially and how we can go about building cross-platform applications with it. So if you don't know what Flutter is a framework released by Google, and it's with the intention of being able to enable developers to build cross-platform applications. So that means, applications for web, for mobile, for IoT devices, and so on and so forth, essentially cross-platform. I had initially been resistant to creating Flutter tutorials, firstly because there's already great Flutter content out there by great developers. Secondly, also, although Flutter is great, it's the underlying language Dart that gives Flutter the power that it has. So all the features Flutter presents is essentially because of Dart, the language. So whether we're talking about hot reloading, we're talking about compilation to native code, all of that comes from the underlying language Dart. So in this video, I'm going to be giving you an overview of Flutter. We're not going to be building any big applications or such, not at this time anyway, but we're going to just be playing with the Flutter API and putting together a basic example. So at the end of this video, you should be confident enough to get started with Flutter development. So over here, we've got a boilerplate Flutter application running. And what that does is it launches a material-based application. And here we just have some text rendered here and then a number which updates when we click this plus button. So I'm not running this locally, I'm running this online. So if you go to dartpad.dev, go under samples and then select the counter example, that should give you this. And then you should be able to run it and then see the results rendered over here. So let's look at the code. In Flutter, they say that almost everything is a widget. So what you'll be doing is your Flutter app would consist of building your own widgets, and then what you'll be doing is you'll be piecing these widgets together to build your UI. So if we start from the top here, every Flutter or Dart application has a main function, and here is where you would actually bootstrap or start your application. So in here we use the run app function which comes with Flutter, and then in here in the run app function it takes in a widget. So in this case the widget here is called my app. There are two types of widgets that come in Flutter. One is a stateless widget and the other is a stateful widget. So of course you would use stateless widget if you don't care so much about holding stateful information in that particular widget. And of course for stateful widgets it will be the opposite. If you wish to hold stateful information, if you wish to have lifecycle methods and so on and so forth, you'd be essentially subclassing stateful widget. If you're from a React background, either React frontend or React Native, a stateless widget is essentially equivalent to having a presentational component or a functional component. And a stateful widget is essentially equivalent to extending React.component. So although there are similarities in React, the difference here is that with a stateful widget, you do not define your stateful information in this class directly. What you need to do is to extend a class called state, and then in this class you would pass in your subclass of stateful widget. So the idea is that in this stateful widget you have initial configuration information which will then get passed to this state class. In here in stateful widget we define a createState method, and then here is where we declare our stateful instance, which brings us to this state class. So it's in this state class where we'll be rendering our widgets, and also we'll have methods to update our state, which will redraw this widget. So if we come back to a stateless widget, however, there is no createState method because we don't need one. We just define a build method here, and this is equivalent. Build method is equivalent to having your render function if you come from a React background. So I'm going to remove all of this so that we can start from scratch. So I'll delete that. Let's begin by declaring a stateless widget. So we'll call it my app, which will extend a stateless widget. So this widget is essentially the root widget in our application. We'll override the build method, which will return a widget. This build method contains a build context, which for now we won't be doing much with, but still good to define it. And then in here, what we want to do is we want to return a material app. So because we're importing material.dart, we can return a material app. If you want to develop for iOS, you could import Cupertino, I believe it's called .dart, and then you could return a Cupertino app. We'll give it a title. This material app takes in a home argument, and here we'll specify the widget we want to render. So we'll render a center widget. A center takes in a child, and in here we'll just place a piece of text saying hello world. And let's run this. Okay, there we go. So if you follow this correctly, you should see the text hello world being rendered here. By default, the text looks red with yellow underlines because this material app expects a scaffold child widget, whereby essentially we should be placing this in. So I will cut this, and then for home, we can have our scaffold here, and then we can specify our body. And let's check this out. Okay, so there we go. So now we got hello world rendered here on the screen, and this center widget takes whatever we place inside it and it positions it at the center, as you can see there. Right, so this scaffold widget also takes in an app bar, which takes in an app bar widget, and this app bar widget takes in a title, and then we can specify a title. So let's run this, and that gives us the app bar here. The scaffold widget also allows us to define a floating action button. So the action button that was down here in the earlier example, we'll say floating action button, and then here we'll specify a floating action button which expects a child widget, and here we can render an icon widget. And in fact, if you select any of these widget classes, you can click on documentation and it should give you some information about it. So if we look at this icon widget, it's expecting an icon to be specified, and then these are other arguments we can specify. So for icon, we've got an icon library, so we can do icons, and if I do dot and wait for a moment, we get all these icons. So these are the icons that come as part of the material design pack. So if you've got Flutter, this comes automatically with it. So let's select the refresh icon. There's a warning because we need to define an onPressed named argument. So let's do that now. And for now, I'll just leave it as such. Let's run it again. Okay, there we go. Got our refresh button here. All right, so at this point, it'll be useful to have a stateful widget to allow us to update the UI and make changes on the fly. I will create a stateful widget. So we'll call it my app state. And then in here, as part of configuration, we'll define a constructor which will expect a title. And then whatever we pass in there, we will assign to title. Okay, so next we need to override the createState method, which expects a state object to be returned. So first I'll do that here. Then in our override method, this will return my app state, and then we'll have the name of the method, createState, which will return an instance of my app state. In fact, let's name this my app page state as such, and we'll name this my app page just to save any confusion. Okay, that should do. And then in here, we will override the build method. And in here, we will return our widget tree. So in fact, I'll copy this one. And then I'll place that here. And then over here for our home, we will instantiate my app page. So let's run this. And yeah, everything else should remain the same. Let's look at how we're able to style the text appearing on our screen. Go to the text that's being rendered in the body, and each text widget takes in a style named argument. We will declare a text style object. So this text style object will take in, for example, we can specify the font size. We can specify a lot more styles. Let's say the color of our text, and then we'll use the helper class colors, and then we can select a whole range of colors. So all of these come as part of the material design system. So we can just go with purple for now. And let's add a decoration to our text. We use text decoration dot, we can use underline. So let's run this and see what that looks like. And that makes our text look like this. There are also widgets that are useful when building layouts. So we can use a column widget, and this allows us to align items on the y-axis. So this column widget takes in a children. So children allows you to define a list of widgets. We'll begin with our text widget. And let me close that off. And then we'll close off our column widget. So let's run this. So if you run this, it looks like this now. So by default, the items are aligned to the top. So if you're familiar with Flexbox layout in CSS, this is equivalent to, for instance, setting the align items property of the parent container to start or flex start, I believe. Column takes in a property, main axis alignment, and here we'll specify main axis alignment. Let's use center. And if I run this, that should center our hello world text. We can add a couple more widgets. Let's add another piece of text. And if I run this, we have these stacked on top of each other. Also, we can set different options for this main axis alignment. So we can set it to end. And we should bring it here. We can say space between, and so on and so forth. So you get a gist. There's also a cross alignment option we can specify. By default, it's set to center, but for instance, we can use start. And if I run this, you don't see much difference, but you see hello again. It's aligned that way. We can set it to end. And if I run that, you see hello again now aligned to this side. Anyway, so let's just use the default. Okay, so aside from having items in columns, we can also have items in rows. So I'll get rid of this piece of text, for instance, and then I'll declare a row widget. In fact, let's not do that. I'll just change column to row, just so you can see the difference. And if I run this, we got an output like that. And let me undo, let me bring this text back, and then I'll change that to row and I'll run it. Okay, so you got these two now aligned next to each other. And the options pretty much remain the same for rows and columns. It just looks different in the UI. So I'll change this back to column. And also, aside from text, another widget that you'll be using mostly is known as the container widget. So this is equivalent to having your divs on the front end, and also if you do React Native, you have the view component. So in here with Flutter, you have container. So container takes in several options, such as, for example, a width. It can also take in a height. Container can also take in a color. So we'll just say red. And if I run this, we get a red square. Also, you can add in a bit more options. So you can specify a child, and in here you can specify some text. So I'll just put J, and then let's style it. And let's say white 10, and it's style. The J is being rendered, but you can't see it because, so let's use the proper white. Okay, there we go. In here. So of course, if you want to center this, you can easily have a center here as such, and then that gets centered. So the way these widgets are designed, you're able to essentially nest these widgets inside each other, similar to how you would be doing if you're building a React-based application. All right, so let's just get rid of this to simplify things. And what I'm going to do here is to declare a row widget. And in this row, we'll specify the children, which is a list of widgets. And I'm going to cut this container and I'm going to place it in here. And let me just indent it a little bit. Okay. And let's add a couple more containers here. And I'll change the colors. So we can say color yellow, colors blue, green, brown. Run this. You see what that looks like? Okay, that gives us this. And we can change the main axis alignment. And we're just going to center it. And for the column, I will set the main axis alignment to center. All right, so the next thing I want to cover is how to update state to dynamically change the UI. We've added a floating action button here, so I will update the onPressed event. So when I click on this, I want to call a set axis alignment function. So it's not defined yet. So let's come over here, and in our class, we'll define a set axis alignment function, or method rather. And in order to update state, we need to define essentially instance members on our state class, and then we'll update those instance members. So for instance, I'll create an instance member called main axis alignment, and let's set that to start. So this is the state property that we'll be updating. So let's set that to our row over here as such. So if I run this, by default it's set to start. So if I click this button, we want to update this variable. To do that, we need to call the setState method, and then this takes in a callback. And in here, we'll make our changes. So we'll say main axis alignment equal to, then we'll just update it. Let's say center, and let's run this. So if I click this, this should now be centered. So let's try that. And there we go. Now it's centered. So what happens is when this setState method is called, whatever is defined in here executes, and after it's finished executing, the widget tree gets redrawn. So that's why this is now positioned to the center. So we can make this a bit more interesting. So I'll define a list. I'll call it main axis alignments containing our various main alignment options. And once I've defined that, so what I'm expecting to happen here is when I click the refresh button, I'm going to select one of these options at random so that at least we can see how that affects the UI. I am going to import an inbuilt Dart package called the math library, and then let's alias it as math. Then I'll come back here, and in my set axis alignment method, I'm going to initialize a random number, and we'll say math.random. And then here, when we are setting our main axis alignment, we'll do main axis alignments. So we'll query our list, and then we'll say random number dot next integer. So that'll start from 0 to the length of our list. So let's run this and give that a go. So if I click that, that should change. Click that, it should update, and so on and so forth. Okay, cool. And let's do the same for our cross axis alignment. So if I copy this and I paste this here, I'll change main to cross. In fact, I'll change all of these. And once we've got all our options, I'll create a random object. And then we need to actually define a cross-axis alignment property. And then we'll give it a default. And then over here, we'll look at our list. Then we'll do the same thing we've done here. Then we'll just change this to cross-axis alignments. And we want this one. And let's adjust the indentation a bit so it's more legible. Okay, I'll leave it as such. And lastly, we will copy this and let's give that to our column. Okay, so let's run this. Okay, so if I hit refresh, it should be updating the cross axis of our column, as well as the main axis, of our row. So we get that. Okay, cool. And this ends part 1 of the overview. In the next video, we'll look at the stack and positioned widgets. If you enjoyed this video, do hit that like button and also share this video on your various social media channels. If you haven't subscribed already, hit that subscribe button, and not only that, hit the bell notification icon next to the subscribe button so that you don't miss out on any updates. If you've got any feedback, let me know down in the comments below. Thank you.